Hey there, Stu here. Today's video, proudly sponsored by marineengine.com, is going to be about this Yamaha 20 horsepower because it's got a few issues. This outboard fires up, runs, but it runs fast, it backfires, all this kind of stuff, so it's not in great shape. I also noticed there was a bit of water leaking from the cooling jacket cover. So what I thought I'd do is just take all that apart, sort of show you the sections of a two-stroke head, what happens when a head gasket goes, show you where the water goes and where it leaks from, in this case, from that final cover. Maybe just to give you a better idea of what's sort of going on in that part of an outboard. What I'll do first though is I'm going to put a compression tester in and we'll just get some compression readings for those cylinders because I haven't actually done that yet. I've got a head gasket for this, so I will swap it out. I've got it, I may as well. But I'll be curious to sort of get some before and after readings. First step in doing these compression tests, just pulling these plugs out as usual. These spark plugs haven't been in very long at all, but they already look quite different to each other. This is a bit whiter, this is blacker, so there's definitely something going on. I have been keeping aside spark plugs as they come out of boats if they've got something interesting about them. You know, they're burning oil, running rich, running lean, whatever. So I'll keep those aside, and when I've got a decent collection, we'll do a whole video on reading spark plugs. For now though, we'll just do a compression test. Really one of the most important things of doing compression test is make sure that you've reset the gauge. You don't want to sort of have used it previously, still have a high reading. If this outboard has a lower reading, you won't get a true reading. So I'm just going to throw this gauge into the cylinder number one and then just turn it over a few times. They say you should have the throttle open for a compression test, but I've got to say, I was talking to Ian once and he said, I don't think it's true. And he said, we'll go on, do one with the throttle wide open, do one with the throttle closed, and the readings were the same, so he was right. That cylinder, top cylinder, gave us 100, which is, you know, not catastrophic, but not great. I also am a firm believer in the fact they say you're looking for a difference, less than 10% difference between all your cylinders, because these aren't highly calibrated instruments, you know, there's nothing to say this is 100% accurate. But we are using the same gauge to measure both cylinders, and that we can trust. So this has given us 95, so they're within that 10% range, that's good. Maybe it isn't a head gasket issue, but I've got a new one, so I'm going to take it off anyway. Now I'll just give you a close-up of the engine itself and show you where it's been leaking from, what's going on. On a two-stroke, you don't have any valves, any camshafts, anything like that. So all we've got is the block itself, the head, which is this middle section, and then a cooling jacket sort of cover here. If we unbolt this, we're actually separating three sections. Spark plugs at the top here, they go straight through this cover plate and then into the combustion chamber through the head here. Next thing we'll do is get these bolts out. I might have a look. Let's have a look over here. It looks like this bracket for mounting the ignition actually bolts into the head here, so we'll have to undo a couple on the side here. Then on the top here we've got the thermostat. I think even if this isn't a head gasket problem with this motor, I think it's just going to be a good exercise to look at how the cooling water works in an outboard like this and how the paint doesn't work. Next step for me is to take all these head bolts out. Given this outboard is quite corroded, I'm going to be quite careful with these because it's pretty easy to snap a head bolt if the outboard's a bit old. On this Yamaha, all the head bolts have 12mm heads on them. I definitely like using hand tools for head bolts because at least to break them, because you'll get a really good sense of whether they feel like they're going to snap or whether they feel like they're going to come out. After that, yeah, I'm maybe more happy to use a power tool to just extract it the rest of the way. But it's nice to get a sense of how it's going to start with. It's not as critical to remove them in the correct order, I don't think, as it is to tighten them in the correct order. But ideally you're sort of starting from the outside and spiraling in. When you tighten them, I think it's really important that you start in the middle and spiral on the way out. Some of the bottom ones I can't really fit a socket in, so I'm just going to use a spanner to get those bottom ones out. They're also feeling a little bit tighter than the higher ones, which is not uncommon. Often you'll find it's the bottom spark plug corroded, the bottom head bolts corroded. They just get a lot more salt water on them. That's what it comes down to. But fortunately, so far, none of them feel like they're going to break. To make it a little bit easier to get to these bolts, I'm just going to take these two ignition coils off too. I would never work around something that you can take off easily. If it's in your way, just move it. It might seem like extra work, but I always think it saves you time in the long run. I'm going to use a ratchet spanner to get these bottom ones out. Ratchet spanners I sort of have a bit of a love-hate relationship with, in that I find more often than not, because the head of them's larger because of the ratchet mechanism, you can't get them in where you need to. You've also got to be really careful with these, because if you put them on a particular fastener and that doesn't have a lot of clearance against something here, if you then sort of wind this fastener out and then it gets to an end and you can't get the spanner out and you can't get the fastener out, there's no way to then move it back in, because it's a one-way ratchet. The only way you can move it back in is to swap it over. So this really is the situation I was talking about. If I'm using a ratchet spanner to pull this fastener out and I get to the point where there's not enough room to take the spanner in this gap here, then I can get to the point where the fastener's out, the spanner won't come off. I can't wind it back in, because the only way I can wind it back in is to take it out, turn it around and do this. So it's just something to be really careful of, because you can get yourself very stuck otherwise. The very bottom two I can't pull all the way out. They do hit against the casing here, but they're obviously all the way out of the threaded section of the block, so we're good to remove the head now. There are these two 10mm fasteners on this sort of ignition mounting bracket, and I'll take those out because they do go into the head. There's a couple of extra fasteners that hold the water jacket cover plate onto the head, but I'm going to leave those on for now because we can get those on once the head's off. Even though all the head bolts are out now, the head's quite often just quite stuck from the bit of corrosion, the head gasket, all that sort of thing. So I'm just going to use a little pry bar just to push it away from the block. I usually try just to get it in a few different locations, see if you can find a part that sort of starts to give, so you're not putting too much pressure on any one point. So it's coming away now. Somebody asked me in a comment a while ago about a similar thing if the actual power head's stuck on. I find prying it, just gently work your way around. Eventually you'll see one section will lift and then you can still work from there. If it doesn't come easily at all, or even with a fair bit of effort, just double check you haven't missed a fastener somewhere, because it's easy to do. There we go. So I'll pull this off. Interesting, you can just see how different these cylinders are. This is quite black and quite oily. This top one's quite clean. Before we look at the head itself, this is what the piston tops look like. I'll just go over this. So at the moment I've got cylinder 1 close to top dead center. I'll just go and see if I can reach from here. There we go. Bring cylinder 2 up. Looks like there's a big chunk of something stuck up here in the water jacket. Nothing solid, just salt and aluminium corrosion. Alright, so we can just take these bottom 2 bolts out now. I couldn't get them out while I was in situ. What I'll also do now is take out these last 2 10mm fasteners so we can take this cover plate off from the head where the cooling jackets are. I'm not 100% sure that the actual head gasket had a leak in it, but I do know for sure that this cover plate was leaking. Once again, it's not going to fall off because of all this corrosion. I'm going to need to pry it off. These two 10mm fasteners are the cover plate for the thermostat, so I'll take that off as well. Once again, there's a little gasket for the cover plate, and you can see here this outboard's been running without a thermostat in it. Running an outboard without a thermostat isn't great. It's better than running an engine with a thermostat that's stuck closed, you know, no question there, because I'd rather have it running too cool than having it overheating. But if it's running too cool because of the absence of a thermostat, then you're not going to get sort of complete combustion, it'll carbon up, a whole lot of stuff like that. So definitely the best option is to have a good working thermostat in the engine all the time. When a head gasket truly blows, it doesn't necessarily, you know, have any sort of catastrophic failure, but you will just see sections where combustion gases have been crossing, oil, cooling water, whatever. And this doesn't seem to have that. It seems okay in that sense, but you can also see it's got a lot of corrosion, a lot of salt all over it. So I think it's a really good time to replace it anyway. The compression test we did sort of verified the fact that there wasn't an obvious failure of one cylinder. So I'm almost thinking this is probably a bit of a ignition or a carburettor problem that was causing this. Having said that, now I've got this off, I'll be replacing the head gasket here and then the gasket that covers the water jackets here. So I'm just going to once again try and find an edge that I can pry up here. Here we go. Just so I can get under it. And then start trying to get this head gasket off. There we go. Changing a head gasket on a two-stroke outboard isn't anything to really be that freaked out about. Changing the head gasket on a car can be much harder. You've got, you know, sort of all your timing gear, timing chains, inlet manifold, exhaust manifold, all sorts of things that you need to take off before you can even get to it. But on an outboard like this, it's pretty simple. Once you've pulled the bulk of the gasket off, you can see here, if I just sort of start scraping, there's lots of material left behind. So I'm really looking to get this back to a clean surface before I put the new one on. So now I'm just going to go and scrape all the rest of this off and make a huge mess. Once I've scraped the bulk of the material off with a scraper like this, I'm just going to use a wire wheel, like a bench grinder, just to clean the surface up a little bit more. As you can see, it's getting pretty cleaned up now. The wheel on there is a sort of brass wheel, so it's quite a soft metal, so it's not really damaging the surface here, but it gets all that last little bit of gasket material off. This is the outlet I was going to look at quite a while ago when I did that remote starter video where the water pump had pretty much just melted. I had an impeller kit, but even the housing had melted. So I'm a little bit worried that this is overheated to such an extent that this head is now warped. So I'm going to use a straight edge, just put it across various angles to see if this does have any sort of cup or bow or whatever. I couldn't find a longer straight edge, so I guess we'll just have to use this one. The idea is you just lay it across the surface of the head and you're looking for an area where it's touching at the edges but not touching in the middle. If you look up in the service manual for a motor and you look at how flat the head of a motor needs to be serviceable, it'll give you a particular maximum deflection, and that's a measurement you can get the right feeler gauge for. The idea is that as you lay your straight edge across the head, you shouldn't be able to slide your feeler gauge between the head and the straight edge anywhere along. If you can, and you've got the correct feeler gauge for the specification, then the warpage of the head is exceeding the specification and it'll need to be machined. In this case, it actually doesn't look too bad. So that's good news given the potential that it had overheated. So you're looking at running a few diagonals, a few different parallels, looking for any obvious problems. But this one looks okay. Unfortunately, cleaning this up is only a quarter of the picture. We need to clean the other side here, the other side of the cover and then the block itself. I've got both sides of the head and the cover plate cleaned up now. Obviously you can't get the block itself to the bench grinder, so I'm just going to use a brass brush on a die grinder to clean that up. Now all the old gaskets cleaned off the water jacket cover and the cylinder head, I'm just going to spray both of the gaskets with a bit of Hylomar, let it set for about 10 minutes, then we'll put it back together. While that Hylomar dries, I'm going to put these head bolts onto a wire wheel, clean the threads up, and then go and see if I can find some torque specs for them. The Hylomar's dried enough now, and as far as I can see, we're looking at tightening these bolts in 2 stages, 14 Newton meters the first time, then 27 the second time. Because they're not symmetrical, these head gaskets can only go on one way. Same thing goes with the water jacket cover. The water jacket had a couple of small bolts that held it on, so I'm just going to put these in and do them up, just to keep it all aligned, and then we'll put the main head bolts through. Before I put each head bolt in, I'm just going to put a little bit of oil on the thread and under the head. That way, when you torque them up, you're actually getting the right amount of tension you need for that torque setting. If they're binding up, the torque wrench will click early. I'm also going to put these bottom 2 head bolts in now, because you can't actually get those in once the head's in place. Now that's in, I'm just going to run along and just loosely put the rest of the bolts in. Now they're run down lightly, I'm going to torque them up in the standard sort of start of the middle and spirals of the outside pattern to 14 Newton meters. These are also numbered on the head, so just tighten them up in the order that the numbers on the head tell you to. Sorry about the rain, hope it's not too loud. I can't get to the bottom 2 bolts with the torque wrench without removing the power head, and I'm not going to do that tonight, I'm running out of time. So what I'm going to do is tighten them by hand, but use the torque wrench on the other bolts as sort of a reference for roughly the ballpark. Ideally we'd use something that's roughly the same length as the torque wrench, so you get a feel for comparing apples with apples. What I'm going to do in this case is use a little 12mm spanner, but I'll put a second spanner on the end so that I've got a handle roughly the length of the torque wrench, so I can get a feel for how tight it really is. To make spanners longer, all you really need to do is, I'm going to use this end, is take the ring end of another spanner and pop it on there, and you kind of lock them, and I'll end up with something that's roughly the length of the torque wrench. That was starting to feel very similar to the others when the torque wrench clipped, so I think it's in the ballpark. Now I've gone up to 27 Newton meters, and I'll do the same thing again. Alright, I'm going to call that good. Now I'm going to put the ignition coils, the thermostat, all that kind of stuff back in, and we'll see how it runs. I realised on the weekend when I went to edit this video up that I didn't really wrap it up properly, so what I'll do is just do some compression tests again so we can get those sort of after readings, and then I'll just start it quickly so you can have a listen to what it sounds like. It still runs terribly, so it hasn't solved the problem, but next week we'll look into the timing and all sorts of other issues that might be causing this backfiring and all this sort of thing. Another point I should make about these compression tests is that ignition coils don't really like to be have power supplied to them when they're not connected to ground. So just make sure you have your lanyard out, so you've sort of essentially got the engine with the ignition turned off. That way you're pulling it over, the pistons are turning, but you're not getting any sparks, so you're not going to damage your coils at all. So that's up to 110 now, slightly higher than it was. That one's about 105. So not a huge increase, but it's one thing we can rule out, and it's no longer leaking water, so that's another problem solved. What I'll do now is fire it up, let you listen to it, but next week we'll actually have a full video on diagnosing the problem. Shouldn't have said that, should I?
Now, if I can't figure out what's wrong with it, you're going to know when I don't do a video. Look at my poor workshop. I'm going to put the fan on and go outside for a while. We'll wrap this video up here. I'll definitely be revisiting this outboard next week to start sort of diagnosing what's going on. I think we'll start by looking at how much oil's in the fuel to start with, but we'll go on from there. Definitely be looking at some timing stuff. That really fast idle you can see seems to be because the timing's too advanced, so I'll be looking at how that's adjusted. I think there might have been an issue with some of the springs, the return springs on it, so we'll have a look at that whole section. Hopefully though this video gives you an idea what's involved in changing the head gasket on a small two-stroke motor. As you can see, it's not a huge job. It can be done with the power head in situ. Taking it off would let me get my torque wrench to those bottom two bolts, but I think if you use a lever that's the same length as your torque wrench and you've had a really recent reference feel of what the torque spec is, you can usually get it pretty close. They're pretty low tension on these heads as well, so I think that kind of makes it a bit less critical than some of the really high tension heads you might get on larger motors. Alright, well thanks again, and I'll catch you next week. See ya. Bye.